This video is also about inverse functions, but in this video we're going to look at rational functions, which was not in the first video, and we're also going to look at domain and range. So our set of steps, it's the same steps as in the previous video. We're going to replace f of x with y, or h of x, or whatever, whatever variable they use, or whatever letter I guess they use. And then we're going to swap the positions of x and y. We're going to solve for y in its new position, and then we're going to replace our y with f inverse of x, or h inverse of x, or g inverse of x. Okay, so let's take a look here. And starting with this first one, first thing I'm going to do step one, which is replace f of x with y. Then we're going to swap the positions of x and y. We're going to take nothing with them. Now notice that I have two x's, which means both of those x's get replaced with a y. We didn't see that before in the previous video. And then now we're going to solve for y in its new position. I'm going to multiply both sides of the equation by y minus 2. And this will allow me to get rid of the denominator, clear the fraction. So I'm going to distribute x on the left-hand side. Sorry if you heard that. I had my phone on there. So we'll end up having, we have xy minus 2x is equal to y plus 3. Okay, so we're solving for y. Now, you may think, ooh, I'll just subtract 3. Boom, I've got y. But the problem with that is this term also contains a y. So if you subtract 3 at this step, you have not isolated y, because you're going to have y on both sides of the equation. So in order to isolate y, we need to get all terms that contain a y on one side of the equation. So what I'm going to do is I'm going to subtract y from both sides. Okay, this will, then I'll have my two terms that contain a y on the same side of the equation. I'm also going to go ahead and add 2x to both sides. That way the two terms that do not contain a y are also on the same side of the equation. Now, xy minus y, I can't actually subtract those. I'll explain here in a second what we're going to do with those. And 3 plus 2x, 3 plus 2x, they're not like terms. I might just call it 2x plus 3, same thing. But 3 plus 2x is also okay. Now, to isolate the y, the little trick we use is we factor out a y, because those terms have a GCF of y. So we can factor out a y, and then it is y times the quantity x minus 1. So dividing by x minus 1 will isolate the y. So we have y equals 2x plus 3 over x minus 1, and that means f inverse of x. So our inverse function is 2x plus 3 over x minus 1. So the inverse of a rational function is a rational function. Okay, let's take a look at number 2 here. Number 2, I'm going to first replace h of x with y. Then I'm going to swap the positions of x and y. I'm going to take nothing with them. So x equals 3y minus 7 over 2y plus 5. I replace both of the x's with y's. Then I'm going to clear my fraction by multiplying both sides of the equation by 2y plus 5. On the right-hand side here, I'm able to cross cancel. On the left, I will go ahead and distribute that x variable to get 2xy plus 5x. Then as we saw with the last one, I'm trying to solve for y, and this term contains a y as well as this term. So we want those terms on the same side of the equation, otherwise we won't be able to isolate y. So I'm going to go ahead, I'm going to add 7 to both sides, and I'm also going to subtract 2xy from both sides. So now I have 5x plus 7 equals 3y minus 2xy. Now I chose to, in this problem I have my 2 terms that contain a y on the right-hand side of the equation. And over here in this problem, I made them on the left-hand side. It really does not matter. The only reason why I chose to do it that way for this problem is I saw that if I was going to subtract 5x and then subtract 3y, I would have had 2 negatives over here. It would have been negative 7 minus 5x. I mean, that wouldn't have been terrible. So that was my reasoning for choosing to subtract the 2xy instead of subtract the 3y. Does not matter though. Either way is just fine. I'm going to factor out that GCF of y, and then I'm going to divide both sides of the equation by 3 minus 2x, and this isolates my y. All right, and this means that h inverse of x is 5x plus 7 over 3 minus 2x. Okay, now before I move on to the next topic of domain and range, I just want to remind you of how I like to check my answers to make sure that I've, haven't made any silly math errors. So to do a check, I like to pick an x value, okay, any x value you want, and plug it into the original function and see what y value you get. I'm going to choose, how about negative 2? I'm trying to pick one where I'm going to get a whole number. Okay, I'm just going to pick negative 2. Okay, but technically, you could pick any x value you want. I'm going to plug it in. Okay, so I'm going to find h of negative 2. So this would be 3 times negative 2 minus 7 over 2 times negative 2, which is negative 4 plus 5. So in the numerator, I get negative 13, and then the denominator, I get 1. So negative 2, negative 13 is a point on the graph of h. Okay, so if I were going to plot this, which I'm not, but if I were, I'm guaranteed that the point negative 2, negative 13 is on the graph of this function. Now, if I have done all my math correctly, then if I reverse the coordinates, okay, so I'm gonna reverse these, that point should be on this graph. Okay, so let's see. So is the point negative 13, negative 2 on the graph of h inverse? Okay, well, let's see. So I'm going to find h inverse of negative 13, okay, and I'm hoping I'm going to get negative 2. If I do, then, I've got a really, really good chance that I've done my math correctly. Okay, not saying that, it's 100%, but it would be really close. All right, so we need to check this here. Okay, 5 times negative 13 would be negative 65 plus 7. 3 minus, so it'd be 3 minus negative 26, which is really 3 plus 26. All right, let's see. Negative 65 plus 7 would be negative 58. And then 3 plus 26 is 29. Negative 58 divided by 29 would be negative 2. Yay. Okay, so it looks like we must have done our math correctly, because when the point xy was on h, the point yx was on its inverse. So that's good. That's kind of a nice way to check your work. Okay, this leads us into domain and range. And hopefully you can see why this is the case based on what we just did to check our answer. So for every point xy that is on the graph of f, since the point yx will be on f inverse, then you might be able to see that the domain of the inverse function is going to equal the range of the original function. And the range of the inverse function is going to be the domain of the original function. They're going to be the same. So it says above, or on the previous page, I guess, we found that, okay, so this was the given for number 1, and this is what we found. You can see it up here. What we found, 2x plus 3 of x minus 1. And we want to state the domain and range of each function. Okay, so here's the function f. Here's the function f inverse. To find the domain of f, okay, we've seen this a lot in this course. We know that division by 0 is undefined. So this means that x minus 2 cannot equal 0. That means that x cannot equal 2. So the domain of our original function f is that x cannot be 2, or if you want to write that in interval notation, this is what it looks like. Just see what your instructor wants. So the domain of f is equal to the range of the inverse function. Okay, so we actually just found the range of f inverse. Okay, so domain of f inverse we don't know yet, but the range, we just found it. Now, the range, you know, I've got this little cheat sheet, I guess, but the range is the set of possible y values. So I am going to copy this domain that we found, but I am going to use the y variable. So y cannot be 2, or we can write it in interval notation like this. And I'm going to show you guys here when I get done why we have that y cannot be 2 for the inverse function. So I'll explain, I'll actually plug it in and show you why. Now, we also need the domain of the inverse function and the range of the original function. We've talked about range, but haven't done a whole lot with it. And in general, it is going to be easier to find the domain than the range. So what I would do is I would find the domain of the inverse function since we have it. The domain would be that x cannot be 1. Okay, again, division by 0 is undefined. So in both cases, to find the domain of each of these, I'm setting the denominators not equal to 0. So the domain over here is that x cannot be 1, or in interval notation, it's going to look like this, which means the range over here would be that y cannot be 1. Okay, so I'm just using the same as the domain of the inverse function, except that I'm going to use the y variable because we are talking about range. Okay, so here's the domain and range of f. Here's the domain and range of f inverse. Okay, but let's just take a real quick look, I guess, at range. I feel like domain, you can definitely see the domain. You can see yx can't be 2. You can see yx can't be 1. But let's look at range. So for the original function, we said y cannot be 1. So let's investigate that. So we want to know why can y not be 1? So let me show you why. I just said y like 5 times. So I'm going to plug 1 in for y or f of x. F of x is the same thing as y. Okay, so let's see why 1 cannot equal x plus 3 over x minus 2. So I'm going to multiply both sides of the equation by x minus 2. That way I will be able to clear my fraction. And on the left-hand side, 1 times the quantity x minus 2 is just x minus 2. And then maybe I'll subtract x from both sides. And x minus x is 0, x minus x is 0, and I get this equation. Okay, that's supposed to be a sad face there. Negative 2 does not equal 3. So when y is equal to 1, I end with a contradictory statement. Negative 2 does not equal 3. So that is why 1 is not part of the range. So the range would be all real numbers except for 1. Any other number I would plug in on the left-hand side there, whether it be negative 10, whether it be 56, whether it be 2/3, I will be able to solve for x. The x's will not cancel out like they did. Okay, over here, same thing. Y cannot be 2. Let's see why. Okay, so this time I'm going to let 2 equal our inverse function here. And I'm going to multiply both sides of the equation by x minus 1. I am able to cross cancel here. So I'm going to distribute 2x minus 2 is equal to 2x plus 3. And maybe I'll subtract 2x from both sides. And once again, I'm left with negative 2 equals 3, which is not true. So now you can see why 2 is removed from the range of the inverse function. All right, so you don't have to show this. I just wanted to explain to you why those numbers are not part of the range. Okay, let's do one more like this. So it says above, we found that h of x was this, and then we found h inverse 5x plus 7 over 3 minus 2x. Just to show you, it's this thing right here. I just copied it down here. So we've already done the calculations. Now we want the domain and the range of each of these functions. Okay, so here's h. Here's h inverse. Domain, 2x plus 5 cannot equal 0. 2x cannot equal negative 5. And x cannot equal negative 5 over 2. So the domain of the original function is all real numbers except for negative 5 over 2. Or if you want to write that in interval notation, it looks like this. Now this is the range of h inverse of x. Okay, so we just found, so I'll leave some room up here, I guess, for the domain, that the range of the inverse function will be exactly what we just found, except for I am going to use the y variable, not the x variable. Because when we're talking range, we're talking possible values of y. Okay, then over here, okay, so here I use this to come up with the domain of the original function. So over here, 3 minus 2x cannot be 0. That's going to help me to find the domain of the inverse function. This means negative 2x cannot equal negative 3, and x cannot equal 3 over 2, because a negative divided by a negative is a positive. So the domain over here is x cannot be 3/2, or in interval notation, it's going to look like this. And we have just found the range of the original function. So the range of the original function is y cannot equal 3 over 2, or in interval notation, it's going to look like this. So because finding domain is a little bit more straightforward, I would find the domain of each of these, assuming that you have the inverse function, and then you've got the range of the inverse. Let me just show you again real quick why, for example, why y cannot be 3 over 2 for the original function. So let's take a really quick look at that. So if I let y be 3 over 2, and I were going to solve this equation for x, I could first start and I could multiply both sides of the equation by 2x plus 5. Okay, and so I can cross cancel there. And on the left-hand side, if I distribute the 3 over 2, that would be, so 3 over 2 times 2 is just 3. So I would have 3x plus 15 over 2 equals 3x minus 7. And then I could subtract 3x from both sides, and I would have a statement that is not true. 15 over 2 does not equal negative 7. Okay, so that just shows you why y cannot be 3 over 2. Okay, again, you don't have to do this. I'm just showing you, I'm trying to verify what we calculated. Okay, last example for this video is to determine the domain and range of the inverse function without actually finding it. So this is a little tougher, but we can do it. We can do it. We're not actually going to find S inverse. We're going to say its domain and range without finding it. So the domain of the original function, we can find that pretty quickly. X cannot be negative 7. So the domain is x cannot be negative 7, or all real numbers except for negative 7, or you can write that in interval notation. Okay, we just found the range of the inverse function. Okay, but I'm going to use the y variable, not the x variable, because if xy is on the graph of f, then yx is on the graph of f inverse. So x cannot be negative 7, y cannot be negative 7. Now, the domain, we haven't found f inverse of x. That would have been nice. Okay, but we're going to try to do this without finding this. So we need to figure out what values can y take on and what values can it not take. So let me just give you an example of something that f of x could be or y could be. So let's say I want to know, can y equal 2? Well, let's find out. 2 equals 2 times the quantity x plus 7. Okay, so then I'm going to multiply both sides of the equation by x plus 7. And I'm going to cross cancel. And I'm going to distribute. And I'm going to have 2x plus 14 equals 2. And I will get a value for x. Okay, so I could subtract 14, 2x equals negative 12, x equals negative 6. So can y equal 2? Yes, it can. I didn't get an untrue statement. I didn't get something like on the previous page where I got 15 over 2 equals negative 7, which doesn't make sense. Okay, over here I got x equals negative 6. So when y equals 2, x equals negative 6. So yes, y can equal 2. So we're trying to figure out what can we not plug in over here, or what can we plug in over here so that we're going to end up getting some untrue statement. There's one number that is going to give us a statement that is not true, and that is, what if I plug in a 0? Let me show you what happens. So can y equals 0? 0 equals 2 over x plus 7. Then if I multiply both sides of the equation by x plus 7, and I cross cancel over here, well, 0 times x plus 7 is still 0, and I get 0 equals 2, which is not true. So I just found out that no, y cannot be 0. So our range of the original function is that y cannot be 0. 0 is the only y value that will lead to an untrue statement here. So y cannot be 0. that turns out to be the domain of our inverse function. X cannot be 0. And so this is the domain and the range of the inverse function. We never even found the inverse function, but we're able to state its domain and range by looking at the domain and range of the original function. Well, I hope you found this video helpful, and thanks for watching.